Financial Modeling, Topic 9, Section 3. In this section, we're going to use convexity to measure the sensitivity of bond prices with respect to changes in interest rates. From our last section, we saw that the relationship between bond price and or value and yield is an inverse relationship. It tends to be convex, in other words, it bows away from the origin. However, if we use duration to measure value change, that'll plot along a straight line. It's a linear approximation of the value change. So say the initial bond value is right here and initial yield is here, and interest rates increase and you're trying to estimate the new value of the bond. Since there's an inverse relationship between price and yield, you use your duration formula and you'll estimate this point right here, taking minus the duration times change in yield times the initial bond value. However, the actual bond value is going to be a little bit higher because of the curvature or convexity of the function. So we have a little error here, a little valuation error due to the nonlinear relationship. We can then correct for this error by using the second order derivative, which measures how the slope of the bond price yield relationship changes. And what we can use is the convexity adjustment. So we're going to first calculate the number of convexity, which one way of thinking about it is the second order derivative in percentage terms. So if we want to calculate this pricing error and adjust for it, we're going to take 1/2 the change in yield squared times the convexity times the initial bond value. And that's going to give me an approximation of that adjustment due to the curvature or convexity. Now the function to calculate convexity is going to be the sum from I = 1 to the number of payments times this nasty thing right here, which is a way of calculating that second order derivative. We won't go into the details. If you want, you can take a look at the textbook for derivation of the second order derivative of the bond function. However, for our purposes, we're always going to have this convexity function available to us. So let's go ahead and calculate the convexity of this bond. I'm going to come over here and I'm going to find the convexity of this 30-year bond. I'm going to do user defined, find my convexity function, type in the coupon, the par, the maturity, the frequency, and the interest rate, the discount rate. This bond has a convexity of 179 units. That's a measure of this curvature. Just for fun, I could make this a 1-year bond, and notice the duration falls to about 0.9 years and the convexity to 1. If I were to make this a 100-year bond, the duration goes to 11 and the convexity goes to 246. So what we see as the maturity increases, the duration increases at a decreasing rate, and the convexity increases at a decreasing rate. But let's make that 30-year bond again. Unlike duration, there's no easy interpretation of the 179 units of convexity. All we can say is if it's positive, it bows upwards. If it's negative, it bows downwards. And the higher the number, the more the curvature. However, we're going to use that number and say equals 1/2 times the change in yield squared times the convexity, anchor that, times the initial bond value, anchor that. That's going to be an adjustment due to the curvature, and this is going to be at interest rate 6%. So it's going to estimate this pricing error due to the curvature and come up with $88. I'll copy that. So I'm going to then take my duration, my linear estimated price, plus my convexity or curvature adjustment, and I get these values, which account for both the first and second order derivatives. Now notice this duration and convexity price is plotted along this gray line here, and it almost tracks perfectly with the actual price yield relationship. However, it's not exactly right. You can see here there's still a bit of an error if you compare bond val with the duration and convexity price. But notice it's very small error, especially for small changes in interest rates. So the reason why it's not perfect is there must be non-zero third and fourth order derivatives or even higher. However, for our purposes and for purposes of in finance, I haven't seen anyone actually take anything higher than the second order derivative, and we generally use duration and convexity as a good duration and convexity estimated prices to be a good approximation of the actual value of the bond. So there we go. We've calculated a duration value. We added a convexity adjustment for the each discount rate, and then we added the duration plus the convexity price and showed that that's pretty close to the actual price yield relationship. In the next topic, we'll talk about mortgage valuations, durations, and convexities.